I am Ashish Sharma. I am the technical product architect in Baker Hughes. Baker Hughes is a service company based out of Houston, and it's a okay. Yeah, I hope I'm audible. Yeah. So today I'm going to cover the topic AI driving digital transformation and how we are doing it in Baker Hughes. So oil and gas industry has always been about engineering at scale. And what we are normally, when we say about AI, is that we go with the hype and we focus on the actual use cases that can deliver operational value. So today what I'm going to do is I'm going to take a higher level view on bird eye view on before even starting with AI, what are the other things that the software companies or the energy companies should be focusing on. So those are the things I'll be covering. So the oil and so what we are changing today is not our mission. We are always trying to deliver the most value in an efficient way. But with AI, what we are trying to do is we are trying to change the tool on how we are going to do it. So AI is no longer an experiment anymore. It needs to be now used in execution. So today I'll share how Baker Hughes is applying AI in a practical and disciplined way, rooted in operational reality and not just the hype. So primarily I'm going to cover three basic things. One is the energy equation, which we are all trying to solve here. The core challenge that limits our usage of AI or the adoption of AI. And the third is how Baker Hughes addresses this through a 4-tier digital and AI strategy. Starting with the energy equation. So energy equation defines today's reality. Global energy demand, we know, is growing, driven not just by the population or the increased consumption, but also by the increased usage by the AI workload and the digitization effort that everyone is going through. So we are kind of in an AI paradox where we are trying to solve energy issues or bring in efficiencies in generating energy while we are consuming more energy while using AI to do that. So also at the same time the industry faces expectation for lower carbon intensity, pressure on the cost and reliability. So oil and gas does remain essential, but expectation is clear that we need to produce more value with higher efficiency and also have lower impact on the environment. So digital and AI are not about replacing hydrocarbons. They are about rewriting the efficiency side of the equation. To go there, we know, like, if you have to develop anything with AI, right? The first is the foundational roadblock that we all face, and it's not exactly related only to the oil and gas industry, but with oil and gas industry, it's a big problem. And like Sanjay sir also covered, that data is the key problem, and we need a good quality data before we can even do anything or attempt anything with AI. So we know that our data is highly fragmented. It's spread across structured, unstructured, semi-structured data. The places where it can be found, it could be on local servers, it could be on people's laptop. It's not centralized at all. So getting that information from all of these places in a format that is understandable is a big problem today. So as a result, data is hard to access, hard to trust, and also hard to connect. This is why AI initiatives struggle today. Like, people jump in directly to develop a use case, but when we go to the actual field setup, we realize that, okay, whatever data we had was very short or it was not comprehensive, and that's where these new cases or the actual field level cases is something that we cannot solve. To solve this, Baker Hughes uses 4-tier strategy. The 4-tier strategy is we take a very disciplined approach in how we are doing this. We are not thinking about AI as the first step. AI is always the outcome for us, and we do not consider AI as the starting point. Each tier builds on the previous one. Like we start with the fundamentals, then we go to the enablement, then the responsible AI tier, and then the actual AI use cases, which gives the operational use case value. So tier one is the foundation where we address the unstructured oil field data, which is where most engineering knowledge actually lives. Through we have a platform called Oil Field Center, and we also have a digital platform that takes care of bringing in the data, cleaning the data, and then making it available to for consumption for any of the use case. Then we have the second tier, which is the enablement. Now, AI, we would want that we use AI to solve the actual field level problems. But even before that, when we are developing software, there are other ways in processes in actually developing the software, we can use those. So in the enablement tier, we enable our developers and technical product managers to improve their efficiency to generate new softwares and create new software quickly, so that the ideations from the ideation stage to the actual implementation we reach quickly. The third tier is the responsible AI tier, which is very important in today's world, because with the AI journey we are just starting up. There can be so many issues that can generate, especially with the oil and gas industry, where one wrong prediction could even cause lives or can be fatal. So that is where the responsible AI part comes into picture, and that's where it is a separate tier altogether. And last is, once we have the all foundation layer, the first three layers in place, we go to the fourth layer, where people use or the developers use this knowledge, this information available, this structure available to then work on the actual AI use cases. Tier 1, the foundation. So here we have a oil field center, that is a product or a platform that allows for a centralized storage. It's a cloud-based storage, and it can also be deployed in a data center or in the countries or companies where there are data restrictions. So this particular product or platform, it allows for large files to be onboarded. It stores them in a secure way, and it also has intelligent capability, like people can search using AI tools with all the data that is available. Earlier, which the file searching or the data searching, which could take hours or days for the field engineers, now that is available at an instant. People can directly do natural language queries and get the answer that they are looking for using this tool. Next is, once we have the unstructured or the historical data in, we have a data platform that categorizes this data into different layers. So we have bronze, silver, and gold layer. So the raw data that comes in by the consumer or the user, that is the raw data, that is bronze layer. Then we do some deduplication, we do some transformation to store it in a format that is available for everyone to use. That is the silver layer. And then we have the gold standard, which can be then used directly by the BI tools. It would be the aggregated data that would be directly usable by different tools for users' consumption. Next is the digital platform. So once we have solved the data problem, we also have a problem where there are so many teams in our company which would be working independently, and they would want to work on so many use cases. Now we don't want everyone to work on the same infrastructure bit, or we don't want them to be working on the same horizontal services like asset management or security or following the best practices. So that is something that we manage by our digital platform. And as part of the digital platform, we also have an IoT platform that allows for real-time data to come in from the sensors, from the field with very low latency. This is the real-time data via IoT platform. So whenever there's a field job going on, be it drilling, reaming, or production, we are actually capturing the data from the sensor from a very remote location that is made available onto the cloud. And that information is then available to the customers or the remote engineers that are available in the office. So it also allows for bidirectional communication. So earlier it was very difficult. Now, if we want, in a controlled way, obviously, and in a secure way, that the person in the office can then send commands to the field and then perform an action remotely. So you don't need to send a large number of field engineers on the field and thereby reducing the cost that you have with it, and also the safety or HSE thing that we have with that. Next is the layer that I talked about, enablement, where we are using AI to enable our developers to get AI-assisted productivity. There we are primarily using two tools. One is the GitHub Copilot and Spec-It. So these two tools allow developers to create production-grade solutions in a very quick time. Earlier, whatever used to take like 2 or 3 months or even 6 months, now that can be done in similar time, in weeks. So it can be done in 4 weeks' time, which earlier took 6 months' time. And even for technical managers, we are not doing that. It's only the developers that should be using the AI tools. We are also encouraging our technical product managers to use AI tools to whatever idea they have, they can directly generate a POC out of it and then use it with the customers to see if that
Ashish, let me ask you a straight question.
Yeah.
You got such fabulous aids now. Will this reduce the cost of discovering oil and consequently the price of oil to a customer?
It would, because...
No, if it's a new technology and it's saving you all the time and effort and blind exploring, so to say, it should end in something that is tangible. And I would say straight away, why shouldn't it lead to cost reduction in discovery of oil, prospecting, and ultimately production?
See,
have you got any such targets from a client or a customer or no?
On the exploration bit, I am not primarily involved in the exploration bit at least. So I am mostly on the production bit where the drilling is happening or the production is.
AI has switched me off.
Sorry?
AI has switched me off. Sorry.
Yeah. Yeah. So, yes. So, like I said, in the energy equation, right? While the push is to go to renewable energies, we would want to still bring in the efficiency, and that's where these tools and processes play a major part so that we can do it in a cost-effective way.
2 minutes to wind up.
Okay.
Thank you.
Yeah. The third tier, which is responsible AI. Now, again, like I mentioned, this is a separate tier within Baker Hughes. We are ensuring that in oil and gas, we know that trust is essential, and decisions from AI can influence safety, asset integrity, and production outcomes. So that's where our framework ensures that we are transparent, we are having a good governance model around it, and also we have a human oversight with whatever we are doing and how the larger team is working. This is the last part where we have the tier 4 engineering and execution, which builds on the top, the earlier 3 layer. This is the place where we deliver direct operational value. So here we can have multiple use cases. That I have mentioned 3 of the use cases. One is the basic AI semantic search engine, where earlier it used to take a lot of time for field engineers to find something. Now that is easier with AI. Second is the predictive failure analysis. So someone mentioned here that we need to get the most most juice out of the equipment that we have deployed. So these kind of analytics helps us with that, where we can predict that the condition of the equipment is deteriorating, and we can do it in a proactive way than in a reactive way. And the last one is this advanced AI techniques that we can also use. So one use case there is the HRVRT, where the team is able to determine if something is being corroded, internal or external to pipe during the casing. And even there, that would help the field engineers to decide if some action needs to be taken or not. Yeah, to close, I'd like to say that AI is not about experimentation, it's about execution. And success in AI or adoption would need us to have a strong data foundation, platform thinking, responsible governance, and also deep domain integration. And then only you'd be able to make the best use of the AI tools that we have for our use.